For Chapter 8, I'm just going to provide an overview because all of the examples in the chapter work through what you should do, and all we're really doing is plugging things into these formulas. So what I'm going to do is provide some insight into how these formulas work. First of all, you can convince yourself that each of these formula sections are not something you need to memorize. And I always am afraid to say that in a class, because as soon as I say you don't need to memorize it, I feel like people start to think that that means they don't need to know it. You should pretty much probably, if you've used them correctly and enough to know how to plug into these formulas, you're going to almost have them memorized. So make sure you work through enough examples that you know how to plug into them. I would be a very, very rich man if I had small amounts of money for every time a student comes in to an exam with a nice little formula sheet and they see them on the work that they plugged in very weird things in very strange places. Yeah, so I guess I'm saying, please don't just say, oh, okay, there's going to be this on the formula sheet, everything's going to be fine. It won't be fine. You should be afraid. And on that happy note, let me talk through my little overview of this. You're going to have this set of information here, so that's all well and good. Here's the example I want to work, and I'm going to focus in on some key things as we go through this example. Based on current information, I expect to live to be 82 years old. I want to retire at age 67, and that's going to leave me with 15 years of retirement that I have to pay for. Every year, the money that I have in my wallet is worth less as inflation happens, and so that means that if I want to maintain my current standard of living in 2066, I'm going to need to have about $3.35 million saved up somehow. All right. And my belief is that my investment skills can net me 6.3% yearly. And so the question is, how much do I need to save every year over the next 40 years to make this $3.35 million so that I can afford to retire and live out the last 15 years of my life in peace and plenty when I am old? So right away, you want to start thinking about annuities. And again, as you work through Chapter 8, the examples that I've recommended on Blackboard, that will tell you what why annuities is the correct thing to be looking for. And in particular, we want this formula right here, because it's going to tell me as information what my yearly payment will be, and that's what P is standing for, given that I want to have a final amount of $3.35 million. So the first thing I do is simply plug in. I'm trying to solve for P. I know what A is. It's going to be $3.35 million. This R is the interest rate as a decimal that I expect to make, so that's 0.063. N is the number of times per year that this is compounded. And this 6.3%, I'm saying is compounded once a year, so N's a very nice number in this example I'm giving us. So I have 1 plus, again, 0.063 over 1. N is the number of times it's compounded per year, which is 1, and T is the number of years, and we're doing the savings over 40 years. So this is the formula I get. Now I can simplify this formula out a little bit. I certainly don't need this divided by 1 here or here. And so I can do some algebra before I'm ready to plug this into a calculator. And this is one of the big things that I think people tend to not like to do once they've got calculators. A little bit of effort with pen and paper. And I do say pen and paper kind of tongue-in-cheek because I'm using a pen that's not an actual pen, and I'm definitely writing on a computer screen here, so it's not even really paper. But the idea is writing something out is actually a fairly decent idea because it lets you plug in the correct things into your calculator. And so at this point, I am kind of ready to plug some stuff into the calculator. Here's what I'm going to do when I use my calculator. Let me call it my calculator here. First, for the top part, I'm going to multiply my 3,350,000 times 0.063. That's going to give me 2,1,1050. That happened to work out to be a nice number, and I didn't have to round it at all. And this is the big thing. Here I'm going to put this in a different color. Do not round off. When you're using your calculators, you're not allowed to go rounding things off. And the reason for that is that if you round off, it's going to give you an inaccurate answer at the end. This is a large enough amount of money that if there had been any rounding that I could do, I would be very much in a big problem. So now let's look at the bottom part here, and you'll see where rounding could cause maybe some difficulty. I've got 1.063, and I want to raise this to the 40th exponent. To make that happen, I'm going to have to switch myself into the scientific version of this calculator. I'm going to hit my exponent button right here. So let's put myself in here, 1.063, and now I'm going to raise this to the 40th. Gives me a rather large number. I subtract 1 from this. It equals, and this gives me 10.51676701, and it keeps on going for quite a bit. I'm going to add this into memory. In this calculator, I hit memory plus. That little M shows up to show it's there. Here's what I'm going to do. I'm going to now calculate this in several different ways and show you what the risk is if you try to round off incorrectly. And this is the biggest block that you can give yourself is accidentally rounding, because usually it's because people don't know how to use the memory feature of their calculator. That's why they bother to round, because it's easier to write down. See, if I look at this 10.5167, maybe I feel very industrious and I write down, 10.52. Let's go back to my color here. So I'm writing down 10.52. If I write down 10.52, I can clear because this is still in memory. Look at the number I get. I plug in 21,105,0, and I would divide this maybe then by 10.52. And the answer I would get would be 20,061. Maybe since we're talking about money, I go all the way out and round it now to 0.79. So if I want to have $3.35 million, this is what I need to be saving every year to make that happen. However, let's look at the other answer I could get, the actual answer. If I take 211,050 and actually divide this by the real number that I had here, instead of that rounded off shorter version, I get myself 20,067.95. Make sure I shouldn't have rounded that. Good. Okay, 0.95. So what I want to emphasize here is the fact that from here on out, these two differ. This one's correct. This one up here is wrong. They're off by almost a little more than $6. Now, of course, in terms of a yearly savings plan, that wouldn't be all that much. But if you, the main deal is that the larger amount of money you start dealing with, the less and less you want to be risking rounding this thing off. And some people would have rounded it even further, maybe rounded it to 10.5. In particular, when you're dealing with very large sums of money, the types of sums of money you might be dealing with if you're investing in a company, or if you're trying to figure out, what maybe General Electric is a large company that has billions of dollars in income, or BP Oil Company is giving billions of dollars to the south of this country to take care of that oil spill problem, more or less successfully maybe. But anyway, they're talking about billions of dollars. This error starts to creep in. Here, with only $3.35 million, which isn't all that bad, I don't have all that much disagreement between the two numbers, but if you start talking about the national debt and you start rounding off, we're talking about a rounding error that's going to be something like several $1 million worth of difference. It starts to show you how maybe, you can't have the usual government horror stories of a $1 million hammer, but it also it's just a little bit less accurate. NASA runs into this as well when they're trying to send space probes off to different planets. Rounding errors account for most of the crash failures that NASA has experienced. You just don't want to run into that. And usually the easiest way to avoid that is to learn how to use the memory feature of your calculator. This is, of course, not the only possible word problem that could be happening in this section. Obviously, there's a whole bunch of formulas that we've got going on here that you'll go and look through and understand. But they're all plug and play once you know which formula to use. And so that's what I mean when I say you can't simply say, oh, I don't need to memorize them. You need to make sure you work with them and play with them enough that when you look and see this and see some sort of set of words, you're like, oh, okay, well, it's not this one. It's going to be the second one over here that's going to let me solve this set of words and turn that into something. So let's go back, and with every word problem as well, your final answer is not a boxed set of numbers. Every word problem, your final answer is something that is able to convey to whoever your audience is what's going on. Why is this boxed number something legitimate that I want to do? Well, what do we have? I wanted to live to be 82, and I want to retire at 67, and that means I need to have 15 years worth of retirement. I've calculated out inflation at a rather high rate maybe, but I'm calculating, I'm trying to be safe. And that told me that I need this many millions of dollars to live through those 15 years at my current level of spending. And I also claim that I'm able to invest at a 6.3% compounded yearly rate. That's my investment skills. And I'm trying to figure out how much I need to save every year for the next 40 years. So I'm trying to get myself out one of these P things. So at the end of the day, when I get my correct answer here, what's really going on is this, and this is more what a final answer for a word problem would look like. I must save this much, $20,067.95 yearly, to be a millionaire when I retire. And that does seem like maybe quite a lot of money, but do keep in mind it's not just all investment. Some of this comes maybe from your pension and from other things. And of course, maybe my standard of living is too high. And maybe inflation won't be as bad as I was predicting. So before it looks like, oh, there's no way that anyone could ever afford to retire, this was very rough numbers that I'm doing with. I guess I'm trying to not destroy your life and say, okay, you never get to retire. So mainly watch out for the rounding errors, particularly. That seems to be the biggest problem I run into in terms of emails from people saying, I think I know the process right, but I can't get the Math Excel to make it work. It's usually this rounding problem. So that's my slight intro, my overview, I guess, of Chapter 8. Make sure you work through all the examples. There are as many examples as possible in that section so that you're able to have a good feel for what all these formulas mean. And again, this formula sheet's going to be given to you. You just have to know which ones to use.